Okay, I'm going to attempt to try to do all your study guide problems here for you. If you need help, email me, and then if I could make additional problems for you, I could try to do that too at some point. Maybe during the video I could try to make problems real quick for you, and then if you want to check with me later to see if you got them right. But here we go. You need to know your marks. You need to know your facts of these shapes: parallelogram, square, rhombus, rectangle. You could Google them. You need to know a fact that's true and mark the figure with appropriate mathematical notation. And I think what he means is these are equal, these are equal. And then I'm not sure if there's some symbol that shows these are parallel versus these being parallel. I'm not sure if there's like a parallel symbol, but in terms of notation, those are equal. These angles right here, this angle is equal to that one. This angle is equal to this one over here. And then diagonals are straight lines that you could draw from only corner to corner. And notice all of these four-sided shapes all have only two diagonals. All of these only have two diagonals. But of course, square has all equal sides, parallel 90-degree angles, rectangle has equal sides, but these two are equal, these are equal. A square has all equal sides all the way around. You could draw those symbols. A square has four right angles shown by a square symbol right there. These are equal. These are equal. This angle is equal to this angle. This angle is equal to this one over here. And then, of course, I'm not sure if there's a symbol to show that these two lines are parallel. These two lines are parallel. I'm not sure if there's some symbol like that that shows that. All right. But again, the proper marks, I believe, showing equal sides, equal angles. Rectangle has all four right angles, just like a square. All right, moving on. This problem right here, they want you to know these terms. Alternate interior means these angles on the inside, but on alternate sides of that transversal. Remember, this is your transversal right here. These are all your internal angles. Alternate interior are on either side. So that would be like angle 4 and angle 6 are alternate interior, or angle 3, angle 5, those are alternate interior, other side of those interior angles. Vertical angles right across from each other. So you got lots of pairs for vertical angles. You can do angle 2 and angle 4 are vertical, or 5 and 7. Any angles right across from each other are vertical, always equal. Alternate interior angles, always equal. These are always equal. Vertical angles, always equal. Corresponding angles, I believe those are equal too. And corresponding, I believe, is like this one right here and this one. I think corresponding. You know what, let me pause the video and look that up real fast. All right, it looks like I was correct. Corresponding angles equal also. Looks like all of these are equal. Corresponding angles would be like 1 and angle 5, or you could do 2 and 6, or you could do 3 and 7. Alternate interior are the interior angles on either side of this transversal, but on alternate exterior, so the exterior angles on either side of this transversal, this one and then the alternate one down here, also equal. Angle 1, angle 7, angle 2, angle 8. Those are alternate exterior. All right, but again, alternate interior are either these two or these two. On alternate sides, interior of that transversal equal. Corresponding angles, this one, or 3, 7, or 4 and 8. Corresponding angles. Vertical angles, 4 and 2. Vertical, same. 1 and 3, same. Vertical. Alternate exterior on either side. This guy and this one, the same. 2 and 8. Or 1 and 7. Alternate exterior. All right, here we go next. List example pairs, supplementary angles, same side interior would be like this. Same side interior, angle 3 and angle 6. Same side interior are what we call supplementary. They add up to be 180. So all those other ones above, alternate interior, vertical angles corresponding, alternate exterior equal. Same side interior not equal. Those two add up to be 180. 3 and 6 is an interior pair, add to be 180. 4 and 5 add up to be 180. Linear pairs, those are angles right next to each other. Those add up to be 180 as well. There's a pair. Angle 5, angle 6 right next to each other add up to be 180. 6 and 7, 2 and 3. All of these are linear pairs right next to each other. 4 and 1 that add up to be 180. They're supplementary. And then the last one here, supplementary, but not same side interior or a linear pair. And what that means is two angles that add up to be 180 are usually right next to each other, or this inside pair. But you could also mix and match other parts. Like if I take this little bit 2, and then maybe look at this 5 right here, those are not linear pairs. They're not same side interior, but those add up to be 180. So angle 2, angle 5, not linear pairs, right? Not right next to each other, not same side interior, not these, but still add up to be 180. So that would be like 8 and 3 add up to be 180. 1 and 6. So not pairs that are right next to each other, not interior, but still add up to be 180. All right, let's keep going. For these, determine if its P is parallel and provide an explanation. And then I could see P is parallel because this angle, which is this one, these are alternate interior, are equal. And I'm not an expert at this level of math, but there's got to be something that says when you have a pair of lines cut by a transversal and the alternate interior angles are equal, that proves that those two lines that transversal is cutting across are parallel. All right, and then this one we worked on together, all the little parts, knowing that if this is 63, angle 6 is 63 degrees. Vertical angles. Know that you have a parallel set of lines with technically a transversal going through them, which means this little bitty angle 18 is equal to angle 3. 3 is equal to 18 degrees there too. Alternate interior for that transversal. And then if I could look at some more, I got 63, 63, 18. It looks like angle 1, they're telling me is 90. So if angle 1 is 90, it looks like I got another pair of parallel lines cut by a transversal. Let me try to show those. Here are these two parallel lines, but this time the transversal is right down the middle. So that means if this is 90, angle 7 is 90. And then if you know angles, this angle 63, angle 6, and this is 90, then this part of the triangle, if I add those up, I know that this missing piece right there has to be what it takes to get that to be 180. So I know that we talked about this a little bit. Knowing transversals cut alternate angles are equal. Know that vertical angles are equal, but then know that the angles of a triangle, like we're trying to find 8 here, we know this is 90, we know this is 63. Those add up to equal 180. So if I take x and 63 and 90 and set that equal to 180 and add those up, I could take that number away from 180 and it gives me what that angle would have to be. So that would have to be, if I could get that right, sorry about that. That looks like 27 degrees. That angle 8 has to be 27 degrees. And then this is a vertical kind of interior angle. This is 27. Angle 2 is 27. And that leaves, let's see, angle 4 and angle 9. If I know that's 63, 27, 18. Let's see, what did I do for this last one? I forget. Let's erase this. So the angles I have now, I know this is 90. I know 2 is 27. I know 3 is 18. I know 6 is 63. I know 7 is another 90. I know 8, because of that hard math I did, is 27. That leaves angle 10. All right, so it looks like, let's see, what did I do here? All right, I'm back. I had to watch that little instructional video that you and I made together to figure that out. I'm not sure why I was blanking, but again, the last piece to find angle 9, which will give you the rest, is the fact that this is a vertical angle pair. That's 63 plus that 9. That pair is going to add up to be 180. So if I add x, the unknown, to 63 equal to 180, and take that 63 away from 180, it will give me what that angle would have to be to add up with that 63 there to get a total of 180, and that is 117. So there we go. That is the final piece of the puzzle. This is 117. That is angle 9. If angle 9 is 117, angle 4 is 117. And then to find angle 10 and 5, looking at the last piece, again back to a whole triangle piece, this 18 plus this 117 plus some unknown angle 10 will give me that added up to 180, give me supplementary. So here I go, that 18 plus that 117 I know, plus the unknown angle 10 I'm trying to find, that equals to 180. So got to add those up, take that away from 180. gives me that final angle, which is 45. So angle 10 and angle 5, 45 degrees. And then knowing all your parts, lady, remember, vertical angles equal. You got two parallel lines cut by a transversal, alternate interior angles equal. And then the last thing I had you do, or two things, for a complete triangle, all three angles add up to be 180. And then the last one, angles right next to each other, straight edge angles, add up to be 180 as well. All right, let's keep going. This says find the measure of x if it's parallel. So here we go. Let's try to figure this out. If this is 46, this is 46 right here. This is 46. It looks like that, to me, it looks like those are three pieces that are equal. I'm not 100% sure. All I know is to do this math right here, this 46 plus these two other x's, I think this is how you need to do it, add up to be 180. So x plus that 46 degree angle that I know goes right here because of vertical angle rule, switching to alternate interior to get that to be 46. That equals 180. So 2x plus 46. Take away 46 on both sides. That's me. Take that away from 180 and then divide that answer by 2. Looks like 67. And that would make sense because if that angle I know is 46 in there, and again, you follow the progression, vertical angles equal, corresponding interior angles equal. That's how I know that angle is 46 right there. And then, of course, if that's 46, it makes sense that this has to be 67 and 67 because those straight angles all added together, guess what, equals 180. All right, let's try this one. For a square, it's a little different. For a square, all four angles don't add up to be 180, which is a triangle, half a square. For a square, all four angles add up to be 360. So for this one, you don't add it equal to 180. You add these up and you set that equal to 160. So I got 17x plus 8. I got that 66 given. I got that 74 given. And I got that 110 given. And I set that equal to the magic square number. All four angles of a square add up to be 360. For this problem, I'm going to combine all my angle numbers together and leave that 17x alone. So that's going to give me 17x plus, when I add that 8 and that 66 and that 74 and that 110, that gives me 258. Becomes a two-step equation. Take away 258 on both sides. .360 minus 258 gives me 102. Divide by 17. X equals 6, but be careful. This problem doesn't want what x equals. Some people are going to stop right there and think they're done. This wants angle M, so guess what? You got to take that 6 and plug it in right there and do the math to really get this problem right, because you got to take that 6 times it by 7, add it to 8 to get that real value of that angle they're looking for, which is 110 if you do that correctly. And that makes sense because 110 plus 66 plus 74 plus 110, guess what? 360. The last one, same kind of problem. You add them up and equal to 360, and then go back in and find that angle y, kind of like we did. This one, they don't give you that, but they give you that symbol. That means that's 90. So let's do that problem right here. Sorry, getting kind of messy here. But if I take that 2x plus 118 plus that 84, the angle given, plus that 90, hopefully you know that square is 90, plus 2x plus 68 from that other angle, and that whole mess equal to 360. For this problem, you're going to combine your x's together to get 4x, and you're going to combine all these numbers together to get a two-step equation. So you're going to get 4x plus 118 plus 84 plus 90 plus 68 gives me 360. Uh-oh, what happened? All right, well, I'll just keep going. This problem is what it is. Take away 360 gives you 4x equals 0. That, when you divide by 4, x has to be 0. So you're plugging that 0 back in for x, which just gives you 118. So angle y for this problem, I believe, is 118. Let me double check, because if I plug in a 0 here, that's just going to give me 68 too. Let's see if x is really 0. So does 84 plus 90 plus 118 plus 68, does that equal 360? Yep. So x equals 0, but remember, it doesn't want the answer for x on this one. It wants you to find angle y, just like number 7 didn't want x. It wanted you to plug it in to find angle m. All right, let's keep moving here. All right, for number 9, for these proofs, if I was you, I would Google these exact words, because you will see there's so many resources on Google when you type in those exact words. All right, let's try this next one. Number 10, find the values of x and y. This looks like Pythagorean Theorem. So this 16 squared plus 12 squared equals y squared. Know your Pythagorean Theorem. Know that. This over here, these are the legs. 12 squared plus x squared equals 15. Know the parts of a triangle. This triangle right here, this part, y is the hypotenuse. So when I do this, I'm going to set that as y squared equals 12 squared plus 16 squared. Gives me 144 plus 16 squared is 256. Add that to 144. Gives me y squared equals 400. Square root both sides, which will have this cancel away. And that gives you y equals 20, I believe. To solve for x, a little bit different, because these are the two legs for x. I don't set it as x squared equals 12 squared plus 15 squared, because x is not the hypotenuse. This one I write it x squared plus 12 squared equals the hypotenuse squared. And that gives me 144. 15 squared gives me 225. For these are a little different. You got to take away 144. and then square root your answer at the end. If I square root that, it tells me x has to equal 9. All right, here's another one. Pythagorean Theorem. This is the hypotenuse. This is a leg. It's important that you know your parts of a right triangle for these. These are the two legs equal to this side squared for this part of the triangle. But remember, the other part of the triangle you have for this part of the triangle, these are the two legs you put together equal to this side squared. So Pythagorean theorem is important that you know your parts. For y, since the unknown is the hypotenuse, I write it like this. For the blue one, x, since x is not part of the hypotenuse, technically I write it like this. So you always keep the two legs together in the hypotenuse in the Pythagorean theorem equal to the longest side. Keep the legs together equal to the longest side. And if you do that math, that gives me y squared. If I can move this down a little bit. 36 squared plus 48 squared equals 3,600. When I square root that, it gives me y equals 60. The blue one, 80 squared is 6,400. 48 squared is 2,304. Take away that on both sides, and then square root your answer. So you get 6,400 minus that is 4,096. When you square root both sides, the square root of 4,096 is 64. So this x equals 64. All right, parts, Pythagorean theorem. Okay, this one, solve for x and then find the measure of the angle. Ooh, even though it doesn't look like it, these are parallel lines drawn by these little double arrows. That's the symbol for parallel. Cut by a transversal, which means this one equal to this one. If this one would have been right here, those would have been same side interior, those would have added up to be 180. But since they're right there, those are alternate interior equal. So I'm going to set these two equal to each other and then solve the variables on both sides equation. I'm going to start by getting rid of the 8, subtracting it to the other plain number on the left, and then I'm going to take away 13x to get that variable over there on the left. And then I'm going to end this problem by dividing. 11x minus 13x gives me negative 2x. You could have solved this equation a little bit different way, but either way you get x is positive 7. And then plug it into either one, doesn't matter because they're both equal. They're both going to give you the same answer. I'm going to choose that top one only because it's positive in there. So 11 times 7 plus that 8 gives me 77 plus 8, which I believe is 85. So that angle, 85 degrees, that's what they're looking for. This is 85. They're not just looking for x. Oh yeah, they want you to solve for x and find the measure. So make sure you clearly show both. There's x, there's the angle. All right, let's keep going. For this one, looks like a transversal. Looks like these are alternate exterior equal. Again, if this would have been right here, that would have been, added up, supplementary, added up to be 180. But because it's right there, equal. So I'm going to write 10x minus 3 equal to 8x plus 11. Variables on both sides. Start by getting rid of the plain number on the left. Stay on that side. Get rid of the variable term on the right. And then go back to your left side and divide. But then take that, plug it into either one to find that angle. And then once you do, that's equal to both. You don't have to do technically both. $67, I believe. So this angle is 67 degrees. This angle is 67 degrees. This angle is what it takes to add to 67 to get 180. So if I take that away from it, that's 113. Know that. Okay, exterior angle. This one on the outside is equal to these two added up. Remember that exterior angle theorem. I know it's kind of weird, but that 17x minus 2, that outside angle, is equal to the two inside angles over there added up. So that gives me 17x minus 2. When I combine my like terms over here, my 70 and my 6, I get 4x plus 76. Comes variables on both sides. Add 2. Bring 17x down, 4x down. This gives me 78. Take away 4x on both sides. 17 minus 4 equals 13x. Divide by 13. Gives me 6. But remember, that's just solve for x. Find the measure of angle QRS. And if you want to know what QRS is, that describes this angle. QRS. That one right there. So if I plug in 17 times 6 minus 2, it will give me what that angle is. So 102 minus 2, 100. So solve for x. X equals 6. Find the angle. The angle QRS is 100. And then for this last one here, 15, vertical equal. So for 15, I have 3x plus 1 equal to that 55. I know that angle is 55, but to solve for x, to know what I plug in here, to do the math to solve for x, I do this algebra. Divide by 3. And that gives you 54 divided by 3. That gives me 18. And then this last page here, for these proofs, again, my advice to you is type these exact words in Google and see what you get. It will guide you. Like when I use Google and typed in proving opposite sides of parallelogram are equal or congruent, it gave me a bunch of stuff and videos to look for. Any of those you type in will give you stuff to look at and study. All right, I hope this works. I hope this helps. You can watch it at your own speed. Good luck.